Right. Another moments question. It's quite easy to work out what's going to be in the specialist portion of the paper, isn't it? Because basically we've only covered moments and electrostatics that the ST classes haven't covered. So you definitely know that you're going to get some moments in electrostatics, which indeed we have got. Okay, so it says calculate the magnitude of force F. Okay, so there's force F. Okay, and you can see they've even conveniently labeled up the pivot for you, and they've even given you the formula. Okay, so they really helped you out a lot here, haven't they? And they've told you the moment. So on this side of the equation, we've got 19. On this side, we've got the F, and then we need the perpendicular distance from the pivot, which of course is that distance there, which we can read off is 0.55 meters. All right. And then if we rearrange that and put that into the calculator, okay, that gets us 34.5454 reoccurring. All right, but as we've said previously, you want to look at the input data to the question. So two significant figures, we want our answer to be to the same number of significant figures as the input data. So that's the best answer there is 35 newtons. Which distance is used to calculate the moment of the weight of the lower leg about the pivot? Okay, so we would use this force, which is the weight, okay, and we want that distance from the pivot, so 0.25 is the best answer there. Okay, now we're putting another support in position, right? And the center of the gravity is so that's 0.25 there, and this distance here is 0.35. Okay. Explain whether force X or force Y is larger. Okay, and yeah, all right. So we need to explain. Now, when you're doing these types of questions, you can choose where you're doing one of these. I mean, typically would have seen this as a bridge support question, right? Okay, they're using a leg on this question, but the physics is still identical, right? You can choose with these sorts of questions. You can choose. You can put the pivot there if you want, okay? Or you can put the pivot there, or you can put the pivot there, right? Well, actually, you can put it anywhere along the leg, okay, but you just end up with a simultaneous equation that you've got to solve. So to keep the maths easy, choosing the correct one of the, choosing this pivot point intelligently is going to be important, right? And it turns out that in this one, to keep the explanation as straightforward as possible, I think that there is the easiest place to put the pivot, right? So now you can see that we can invoke the principle of moments, which is that the sum of the clockwise moments is equal to the sum of the anti-clockwise moments. Now, force X, if you think about it in terms of there's the pivot, force X is going to be the force that's trying to make it go clockwise. Force Y is trying to make it go anti-clockwise, right? So you can see that we're multiplying Fx, okay, times by dx, that's going to be the kind of distance on the left-hand side, that's 0.25. And then we've got Fy, okay, times by dy, like that, right? And then in the question, it tells us that this is 0.25, okay, and that this number on this side is 0.35, okay? So then the only way that we can make this balance is if this is a larger number, okay, and this side is a smaller number. Why? Because this is a larger number, so you need to multiply a larger number by a smaller number, and you'll get on this side a larger number multiplied by a smaller number. All right. I think that's the clearest way that you can explain that one. So now we're going to put a bag of ice on the lower leg vertically above the center of gravity. Okay, this causes force X and force Y to increase. Okay, and then the bag is then moved towards the person's foot, right? Okay, so it's already told you that both of these forces are going to increase. So maybe I should add to my diagram in a slightly different color. Okay, so that we can see the kind of additions. So here's your bag of ice. Okay, when you do that, force X is going to increase and force Y is going to increase. And then you're going to move it in this direction and it asks you what happens to those two forces. Okay, now look, this is absolutely critical here. They're asking you to describe. They're not asking you to explain. Okay, they don't want any explanation at all. Okay, so as we go in this direction, okay, then as we get closer to this support, then obviously force Y is going to increase and force X is going to decrease. Okay, so that's all we're going to say. Force X is going to decrease, force Y is going to increase. So all I've done there is haven't explained, I've just described. How many marks do you think that's going to get me? It's going to get me 1 mark for that. It's going to get me another mark for that. So I've only got 2 marks so far. So how can I get that third and final mark? Okay. Well, again, I need to describe. Okay. And the description that I can come up with is that fx plus fy is still going to be the same. Okay. Right. So let's say, we started off with this force being, 90 newtons, and this force being 70 newtons. Then as I move it over to the right-hand side, maybe this force changes until it's 30 newtons, right? But if this force has decreased by 60, okay, then that means that this force must have increased by 60, okay? So you can see that the total of, at any point on the beam, Fx plus Fy is going to be the same, okay? So that third point was pretty challenging to get, okay? And it's because not everybody read that keyword there. They're not asking for an explanation. They're asking for a description of how the force changes, right? And that is the end of the paper.